Good afternoon, everybody. My name is Kelly Nijaporek, and I'm with Lakeland Agricultural Research Association. With us today, we have Emily Olson. She's a tech transfer program technician with the Alberta Beekeepers Commission. She's going to be going over Apivar Resistance that I think a lot of us struggle with. So I'll turn it over to you.
Thank you. So my name's Emily. I'm the technician with the tech transfer program. Just tell you a bit about myself before I get started. Before I started with the Alberta Beekeepers Commission, I was a bee inspector for the government of Alberta. So I have a bit of background in bees. I used to have my own colonies, but don't anymore. So I'm just kind of focusing on bees through work. So today I'm going to be talking about Apivar resistance and kind of the situation here in Alberta. So just can't get to my next slide. Hold on. Technical difficulties. All
right, can you still see my screen if I do that? Oh. Can you see the presentation?
It's just a black screen at the moment. Oh, there it is.
There it is? Okay, perfect. Okay. There we go. Right. There we go. All right, so here's a bit of an outline for today. I'll start off by doing a bit of a background on bromites, their biology, impacts they have on bees, and then we'll get into Apivar, go into some background on that, and then we'll get into resistance and the situation here in Alberta, what is currently being done on that, and then next steps. And then to finish off, I'll talk about some other issues facing the industry, and then we'll have time for questions at the end. So the bromite is an external parasite of honeybees. They're the most serious threat to honeybees, and without management, the colony will most likely die. So bromites feed on the fat body of adult and developing bees. They're what's called extra oral feeders. So that means they use enzymes to dissolve that fat body. And this could cause damage after the mite is done feeding, reducing the bee's immune system and overall lifespan. So this is kind of a pretty cool photo I found on the internet. It's taken using an electron microscope, so you can kind of see the impression that the mite leaves on the bee's abdominal wall. And this is the black arrow is pointing to the hole that the mite drills into the bee to feed on that fat body. And then these are the foot pads that are left behind after the mite is removed. So bromites have two life stages, the reproductive stage and the erratic stage. The reproductive stage is when they're in that root cell and will last around 11 days in a worker cell and then around 14 days in a drone cell. They especially like drone brood as the cells are bigger and the development time is longer, so they can reproduce more effectively. And then they have erratic stage, so that's when they're out in the colony. So here's a diagram of the development of both honeybees and mites. So around day 9, of the bee's life cycle. The mother mite will enter the brood cell before it is capped. And then she will drill a hole in that prepupa to feed. And then she will, around day 12, she'll lay her first egg, which will be unfertilized, and that will be the male. And then each day after, she will lay a fertilized egg, and that will be female. And so the mites were growth before. Those daughter mites and the male mites, they reproduce on a pile of feces. And then once that bee emerges, those mites emerge. So for one mother mite, there'll be around 5 daughter mites that will go on and infect other bees. So just the female mites will go on and infect bees. The male mites will, after they reproduce, they will die. So it's very easy for those mite levels to get out of control if you're not monitoring and treating your colonies. And then the Frederick stage usually lasts 5 to 7 days. This can be longer if there's no brood present in the hive, like in winter, which can be 5 to 6 months. Those mites will overwinter on the adult bees. So they can be found, on the thorax of adult bees, the drones, and the workers. Or between the abdominal segments, feeding on the bee's fat body. Varroa typically prefer nurse bees, and this is probably due to their proximity to the brood, and because nurse bees have larger fat bodies for them to feed off of. And they can sometimes be found on forager bees, most likely to find a new host colony. So Varroa spreads to other colonies through robbing, drifting, when you're combining colonies or exchanging frames between colonies, or when you have high density of colonies in one area, or when you're catching swarms. So you catch a swarm and you put that swarm in the yard with all your other colonies. You don't know what diseases that swarm have, so it's good practice to isolate those before you introduce them to your yard with all your other colonies. So Varroa have a wide range of effects on honeybees. They can cause nurse bees to forage earlier. So young bees that switch to that foraging life stage are usually less efficient at gathering resources and are less likely to return back to the hive. And this can have repercussions for the entire colony. Well, Varroa effects can cause learning and navigational impairment. This can lead to drifting, immunosuppression, causing bees to be more susceptible to other pathogens. And all this leads to an overall reduction in lifespan of the bee. And Varroa mites can also have a huge effect on the overwinter survival of our colonies. So summer bees and winter bees have physiological differences that help them survive their respective environments. So here's a photo of a summer bee fat body versus a winter bee fat body. So this white stuff here is that fat body. So fat bodies are essential for the survival of bees throughout the winter. It's important for detoxification. So that fat body is kind of analogous to our liver. It's also important for immune system function, energy storage, that kind of thing. So it's critical that we effectively control our mite levels, especially in late summer or early fall. This is when winter bees develop. So we want those bees to be healthy and develop in a mite-free environment. And this will give our bees the best chance at survival through those winter months. So mites also transmit viruses as they're feeding on the bees. So deformed virus is one we see a lot alongside high mite levels. The bees will be born with a small body size, shriveled up wings. Varroa destructor virus is another one we've been seeing a lot more of. It's the more virulent strain of DWV. Sackbrood virus is another one, similar to symptoms of the AFB, but if you pull out that larva, it will remain intact and appear like a fluid-like sac. So viruses can persist in the colony even after you control your Varroa mites. So it's really important to maintain low mite levels, keep those mite levels down. So just to kind of show you the relationship between Varroa and viruses. So this is some of the data we collected from our colony health monitoring program. This data was collected from about 28 beekeepers across the province in the spring and the fall. And then a subset of the beekeepers we sample in the summer when they're in canola pollination. So the data on top here is from 2020, and low is 2021. So as you can see, mite levels increase as the season progresses. And as you all probably noticed from your own colonies, 2021 was an especially bad year for mites. And this was most likely due to that long season, which allowed those mite levels to really build up. And then here are the virus levels from those same years. So you can kind of see the same trend here. They kind of increase as the season progresses. So Varroa levels or virus levels will kind of follow Varroa levels. So if you have high mite levels, your virus levels are probably also going to be high. Unfortunately, there aren't many options for treating viruses, but some things you can do to minimize viral infections are making sure your colonies have good nutrition. This is critical for the bees' ability to fight disease, detoxify pesticides, that kind of thing. You can re-clean your hive. So some viruses are transmitted vertically, so from queen to egg. So re-cleaning can help reduce the viral load in a colony. Also, you can re-clean with hygienic stock, which can help fight infections. Implementing biosecurity practices into your operation. So that's things like scorching your hive pool, regularly washing your bee suits, isolating sick hives, that kind of thing. This is key to keeping our colonies healthy and preventing the spread of diseases from one colony or one apiary to another. And the main thing you can do to minimize those viral infections are controlling your mite levels. So we really stress the importance of monitoring your mite levels. You'll probably get sick of me hearing me say that today, but when we start seeing Varroa mites in a colony, then you kind of already have a mite problem. They're hard to see, especially when they're in between those abdominal segments. So monitor regularly. We like to monitor once a month. And this allows you to catch it early and prepare and make a management plan. It's also a good idea to monitor before and after your treatments. So you can see how those treatments are working. Maybe if something isn't working, you can look into figuring out why. So on our website, we have a Varroa mite sampling guide. And this goes through the steps on how to do an alcohol wash. There are different ways, sticky traps, sugar shaking, but this is the method that we use. There's a link at the end of this presentation to our website if you want to check that out or refresh on that. So once you have established that you have a mite problem, then you need to decide on how you're going to manage that. So these are the treatment thresholds, and they vary by season and by how you're monitoring for your mites. So an alcohol wash, 1% infestation in the spring, 3% in the fall. Sticky board would be mite drop of 9 mites for 24 hours. In the fall, it's 12 mites. As I kind of mentioned before, visual inspection is not an accurate assessment of your mite levels. There are a lot of treatment options, organic, inorganic, all with different requirements, timing, and instructions. So also on our website is this Varroa mite treatment fact sheet. We've kind of compiled all the labels and instructions all in one place, so hopefully make that decision a little bit easier. So this first page just kind of goes over, best treatment for that time of year. And then the next page will have all those labels and instructions. So now we'll get into Apivar. I'm sure many of you have used or seen Apivar before. It's a polymer strip with the containing amatraz, which is the active ingredient. It works by contact, so the bees need to walk on the strip, pick up that amatraz and distribute it throughout the colony. And Apivar is a slow release treatment. So unlike, past treatments like Apisan or Varroa, which act very quickly to kill the mites, Apivar takes some time to work. So don't be alarmed if you're, not seeing a high mite drop right away. So this is a recommended dose, 2 strips of Apivar per 5 rings of bees, or 2 per brood chamber. And you want to place those strips, inside the brood area. And if you're, you go back and you see that brood area, that cluster has moved, feel free to move those strips around. You want those strips to stay within the brood area for that treatment to be effective. And you want to leave those strips in for a minimum of 42 days and a maximum of 56 days. And you don't want to reuse the strips. It's important that you store those strips properly. They have a 2-year shelf life. It's best to use the strips, right after you open them. The efficacy of that amatraz kind of reduces if you open the strip or open the package and leave it for a while. So it's best to just use a new package every time. So there have been reports of a reduced efficacy of Apivar in the past few years. So what does this mean? In Canada, there haven't been any confirmed cases of Apivar resistance, but basically we just don't know if there's resistance or not. We're just beginning that work of investigating this. So we're hearing that Apivar is not as effective as it once was, but that could be due to many factors. Resistance is very complex. I'm not an expert in resistance, so if there's something that I can't answer for you, I know where to find the answers, so I can get back to you on that. But basically, there's no scientific consensus on an efficacy threshold. At what % effectiveness of Apivar would we consider there to be resistance? That hasn't been established yet. So we can't really say if there's resistance to Apivar in Canada because we have not defined that or done the work to determine that. So some conditions that may cause synthetic miticides to perform poorly. So we've seen cases of Apivar not being used properly. So, improper placement, incorrect dose, and not enough strips. Too many strips, not leaving them in long enough, store them properly, that will reduce the efficacy. If you're spot treating, so as I mentioned before, Varroa can spread between colonies pretty easily, so we recommend treating that entire apiary. There's large amounts of brood in the colony. Those mites will be in the brood cells, so they're not being exposed to that amatraz. High mite levels, so especially this last season, we saw really high mite levels. If you're not monitoring, then you don't know what you're starting out with. And so you can't really tell how effective that treatment is. So say Apivar is 85% effective, and you have a mite level of 25 mites per 300 bees, you're still going to be left with 3 mites, which is a treatment threshold. So this doesn't necessarily mean that Apivar wasn't working. It just means that you had really high mite levels, and you should consider a follow-up treatment. So this is why we really stress the importance of monitoring. That being said, there has been resistance to past miticides like Varroa, Apisan, checkmate. It's inevitable with any chemical treatment that resistance will develop eventually. And if we're not careful with how we're using Apivar, we will only accelerate that resistance. And that's really scary for beekeepers because it doesn't leave us with a replacement for Apivar. There's currently being work done on developing new miticides, but that work takes years, takes lots of resources, money, expertise. So we want to prolong that as long as possible. So why does resistance happen? So let's have a little refresher on natural selection. So genes get copied and passed down to the offspring. Small mistakes or mutations in the DNA make the offspring different from the parent. And sometimes these mutations give the offspring traits that allow them to survive, reproduce, and pass down these new traits. And so individuals with these more successful traits will become more common over time. So by using miticides, we're kind of forcing these pressures on mites in the form of like unnatural selection. But there's some things we can do to slow or prevent this from happening. So I'll go through a bit of an example on how miticides affect a mite population. So let's say this is our Varroa mite population prior to any treatment. Let's say we apply Apivar in the spring. So this is our population after that treatment. So these mites with the R, they're the ones, maybe they have a resistant gene and they survive. But no miticide will be 100% effective because we want to make sure we have mite population remaining that is still susceptible. So then these mites go on and they reproduce. And now this is our new mite population. So let's go and use Apivar again in the fall. Our population now will have a higher proportion of those mites with that resistant trait. So this is our new mite population. Now, if we were to go back to after that first treatment and we were to apply an alternating treatment, different treatment, then that new treatment would kill those mites with that resistant gene, leaving this is our new mite population. So it's really important to alternate your treatments and not rely just on Apivar. So they're not selecting for those mites that have resistance. So some conditions that can accelerate resistance, step 4, using the same treatment repeatedly, leaving strips over winter. This can leave residues in the colony, causing a low level exposure. So those mites can kind of develop a tolerance. Using the incorrect dose, that can also cause a low level exposure, or if you're using too many, you're kind of forcing you're selecting for those mites with resistance, and then unfinished treatments. So how do we test for resistance? So there has been genetic testing of mites to test for resistant genes. This is relatively new for Apivar. Other regions have found resistant genes, but resistance may not have developed the same way in Canada. So for example, the resistant gene found in Spain is different from that found in the US. So we just don't know yet. And some tests that we do here, there's the Pettis test. So these are placed in a mason jar with a screen lid, along with a measured piece of miticide. And then they're left for 6 hours. And then the jar is tipped upside down and shaken, and the mites that fall are counted. And then we do a mite wash to count the mites remaining in the jar. So you can kind of determine the efficacy of your treatment that way. And then there's the apiarium method, and I'll go over that in a few minutes. So this is some data from the government of Alberta from their 2019 resistance testing. So they used the Pettis test, and they tested 24 apiaries from 14 beekeepers. Samples were collected and then tested again using ApeStan, Apivar, Varroa, and then a control. So as you can see here, there's high variation in effectiveness of ApeStan and Varroa. And then these two Apivar outliers, they were retested, and they are found, 90% effective. So this is the mean mite kill number. So Apivar is still working pretty well here. But we want to continue with this testing as we are still hearing reports that Apivar is not being effective. So last year, the Alberta Tech Transfer Program, along with the government of our Alberta Bee Health Assurance Team, we launched a Apivar Resistance program. So we used a different method than the 2019 test, and we just tested on Apivar. So we had beekeepers sign up, and then we would mail them sampling equipment, and then they would be required to take those samples themselves. But this is a bit tricky, beekeepers get busy in the summer, and so a lot of them weren't able to find the time to take those samples. So we were only able to test 5 beekeeping operations. So I'm going to go through our process on how we do that. So first, we do a mite shake with alcohol to determine the infestation level. We need there to be a minimum of 3% mites, so 9 mites per 300 bees. Last year, we had a problem with too many mites. So when we received those samples, the bees were pretty much dead or didn't survive the duration of the test. So this year, we want to look into a maximum infestation level as well. So once we determine that the colonies with the high mite levels, we then take a live bee sample. So these boxes here, we put the live bees in there. So this is a bit of a video on how we take those samples. So each of these boxes will contain bees from 1 colony, and we take 9 cups of bees per colony. And then once back at the lab, we put these bees in apiariums. So this was developed by Dr. Alberta. So we cut the bottom out of a 250 milliliter plastic cup and replace that bottom with a mesh screen. And then this is placed in a 1 liter cup along with a measured piece of Apivar, some sugar cubes, and then underneath here is a petri dish with a sticky board. So we place the bees in there, and then they get placed in the incubator for 6 hours. And then we count the mite knockdown after those 6 hours. The next step, we do a mite wash in our lab to figure out the mites remaining within that cluster. And then from those numbers, we can calculate the effectiveness of that treatment. So of the samples we analyzed last year, we had an average efficacy of 62%. That doesn't look great, but remember we had a very small sample size. And some of those had way too many mites, some had not enough. So it's not really a fair evaluation of the strip. There's a high variation among operations, between operations, within operations. So we can't really make a conclusion regarding the efficacy of Apivar based on these results. So this year, we're going to continue with this program. Last year, we kind of considered a bit of a trial run. So this year, we have 1 dedicated summer technician to go out and take those samples. This will provide consistency, and hopefully we can collect many more samples to test back in the lab. The number of participants will be limited because we have limited capacity, and we'll be targeting beekeepers with 50+ colonies. But if we're not getting the numbers that we want signing up, then we will open it up to people with fewer colonies. So some next steps, we need to incorporate other management techniques, so we're not accelerating, that resistance Apivar. So CAPA is working on a label for an oxalic acid mid-season treatment, and they will give that label to Canadian Honey Council, and they'll send that to PRA. This is just an extension of the current label, so hopefully that will happen quickly, and we can have that treatment for the summer. Fingers crossed. CAPA has also formed a committee to tackle this problem. Dr. Brady and Dr. Rappel will hopefully be working on some miticide research. And then the Alberta Beekeepers Commission has committed to prioritize funding and support of Varroa and miticide research. So as I mentioned before, developing miticides takes a lot of time and effort. So we should consider other options and not solely rely on those synthetic miticides. So what can we do in the short term? We can put our efforts towards monitoring, using alternative treatments like organic acids, make sure that we're using those synthetic products responsibly. Use alternating treatments. This can enhance the efficacy of our current products. This is also a way to manage resistance. So with synthetic miticides, some form of resistance is inevitable. So developing a new products is not a long-term solution. Continuing research into developing new products with different modes of action is necessary. By investing our resources into these short-term and medium-term paths, we can prolong having to rely on the development of new chemical treatments. So what can you do? Make sure you're following those treatment labels. So make sure you're using the proper dosage on timing and placement of those strips. Rotate your Varroa mite treatment types. Monitor your mite levels. Consider using a follow-up treatment if that first treatment isn't as effective as you wanted it to be. You can participate in the miticide resistance program if you are concerned. And then create an IPM strategy. So this is IPM Pyramid. So chemical options are at the top of this pyramid, which means they should be a last resort option. We should incorporate cultural mechanical methods into our management so that we can rely less on chemical intervention. So things like introducing resistant stock into your operation, using spring bottom boards, or opting for organic treatments such as oxalic or formic acid. However, you should not solely rely on cultural mechanical methods to control your mites. It's really important you monitor to make sure these efforts are working. If you're saying drone trapping, you need to be very careful with that. Timing is everything with that. So if you're not removing that drone brood at the right time, you're essentially just creating a mite farm rather than controlling your mites. So some other issues facing the industry. Erratic weather we've been having affects disease and pest profiles. So in 2020, we saw a higher incidence of EFB in the province. Typically, we see EFB in the spring, but it seemed to persist throughout the season. We had a very wet weather that season, so that probably contributed. And then the long season last year really contributed to those high mites that we were all seeing. Well, drought will affect nectar resources, leading to a reduced honey production. So this, we also saw higher levels of black glyphosate in honey. So glyphosate is Roundup, one of the most commonly used herbicides. And glyphosate can impact bees' gut microbiota, larval development, that kind of thing. So what can you do? You can give your colonies the best chance by ensuring they have good nutrition. Feed them pollen substitutes, sugar syrup in times of dearth. You can place your colonies in a site that has access to plenty of floral resources. Ensure they have an accessible water supply, plenty of sunlight, protection from wind. Regularly inspect your colonies so you can catch a problem early before it gets out of control. It's much easier, to remove one frame of brood that has maybe 1 or 2 cells of DFB than to shake your bees all into new equipment. So yeah, monitoring, inspecting your colonies, really something important that you should do. So as I said, this is a link to our website, to the QR code that will take you right there. There's lots of good resources, lots of educational material, and list of our services. With that, does anyone have any questions?
So if people want to type their questions either into the chat or into the question and answer slot, that would be great. I do have one question in regards to the research that was being done, and now it's being transferred to British Saskatchewan. And I think they've been working on 3 different miticides, and they're kind of predicting that it's going to be a 3-year range before they get registered. Do you think that's realistic, or do you think there'll be anything impeding that?
No, 3 years sounds right. I mean, if that research has, I know that some research has already been started. So if it's a continuation of that research, then hopefully we'll get it soon. Yeah.
I guess if people were interested in having their colonies tested for commercial beekeepers and stuff like that, or be part of the program, the monitoring program, how would they go about doing that?
Yeah, so you can go to our website and register. And just fill out, we have a kind of a PDF registration form, so you can fill that out, and it has all the information on our website and the list of prices. So we have a maximum of 3 apiaries per beekeeper, and we do 10 colonies per apiary. But you can just do 1 apiary up to 3. And there's different levels of testing. So you can get your bees tested for viruses, scalp rouge, Nosema, Varroa, or you can just do the Nosema and Varroa. We also have a self-sampling option that's a bit cheaper, so you can take the samples yourselves and then send them to us.
Awesome. Okay, we have a question that came in. She's looking for some advice on how to keep 20% of her hives that have made it alive. Should they continue using like Apivar, or what should they be doing?
Yeah, so if you use Apivar in the fall, I would say maybe use something different in the spring. Yeah, just monitor, make sure they have enough food, and that your site has enough floral resources, because that will really help them survive and make it into the summer. Okay.
She used formic or oxalis in the fall. So.
Okay. Yeah. Then you can definitely use Apivar. We kind of say it's better to use Apivar in the spring. There's less brood presence, so you don't need to use as many strips. And then you can take them out at the right time. If you're using it in the fall, our weather is so unpredictable that it might snow, and then you might not be able to get those strips out. So you can definitely use Apivar. If there's any other questions that people think of, feel free to email me. Kelly has my email address. You can forward those along to me.
Okay. Seeing that there are no other questions coming in, I want to thank you for your time. Hopefully this helps some people out, and that it's a much better season than it was last year. I know my own bees struggled a little bit with the drought, and it was the hot weather. So have a really wonderful rest of your afternoon, and thank you again. And if anybody wants Emily's contact information, please feel free to email me and I will forward it along.
Thank you.